lines. We're gonna do that. Cool. All right, folks. I got them done. You don't know. That is not. Or they did lose it. How many days it's been sitting in the conference room? On my imagination. I was looking for it this morning. I was putting everybody else's grades in. It's like, where the hell is it?
You can keep mine and just tell me what kind of pizza it was. I thought I got like 72. I thought I failed this thing.
Where'd Brett go? I want to be here for the unveiling. Okay, you're not. Is that a holiday? I forget to get invited. No tracker this one.
I told her not to go this short. My brother's girlfriend says I look like him now. So she likes my hair better.
Is that who did it?
All did it.
Could be worse. All right. So the grades weren't horrible. They weren't great. But I'm not going to allow you to redo this one. But I am going to do something to give you another one down the road here for some similar things. But I also realized we might have went too long on topics. So, and the problem was though, I got a couple 99s, and for those who got the 99s, I apologize, but I had to mark the 1 point off because I did it for everybody else. Pissed me off. But I had 3, 4 A's, a whole bunch of B's, a lot of C's, a couple D's. And if anybody ever sees Wally, right now he's holding an F. So anyway, perfect? No. You guys understand what you're kind of doing? Yeah. Some of it is a little disappointing. That's why I want to do something else where you do it again, but I got to find some time to make up some new questions. I thought I was. No, that was when I slid it across your table right there. Yeah, I'm sure there was a ring right there in it. No. When I graded yours, it was Saturday night watching Abbott and Costello meets Dracula, Wolfman, and Frankenstein. So, yeah, there was beginning to wonder what I was actually, which horror movie I was watching. Okay, comp paper. Who needs comp paper for today? Sarah, you got some or you need some? Not over here, anybody? Oh, you get more than one. There's nothing about this project that says.
If you want to give me a couple signs, I just go.
I don't care. I didn't make it up.
I didn't take mine either.
Kevin?
I got some.
Okay. Alright, so. And I spent all weekend looking for the stupid building too, which is another thing. So we're going to draw this out for you. And someplace I'm going to find that drawing and I'll give it to you. But there are dimensions on this building that you need to have in order to do this.
This is project code.
This is actually lab number 10. Okay, so what we got is Okay, so we got a roadway here, and you're going to shoot, depending on which group you are, you're going to shoot either north of the road or south of the road. Okay, so I'm going to do group 1 and get you started, and then you guys can figure out where you are. But we're literally looking at, let's say, where'd my numbers go? Oh, there they are. This is 12 plus 0, 0. This point right here will be 12 plus 58.71. Guess I can make that just a little bit bigger. Okay. And then somebody's going to shoot a point here. Where'd it go? This one is 12 plus 34.65. Okay. And this one's going off in this direction, and this one's going off in this direction. Okay. This just happens to be lot 1. This one's lot 2, and so on down the way. Okay. And I do need to make some copies of that for you, and I will get some done. But generally, what we're looking at is this is the building you're going to lay out. So we'll come back to the layout here in a minute. Okay. But we have this building that looks like so. Okay. So we got this building. I'll put the dimensions in red for you here. From this point to this point, 20 feet. I actually do it in surveying terms, 20.00 feet. From this one to here, 10.00 feet. Okay. Then we have .00 feet. And then we have 8 feet. Okay. Nope, sorry, this is 10 feet. Got my numbers wrong. This one here is 8 feet. And then we have 12.00 feet here. Okay. Then we got B located here. C, D, E, F, G, H, I, J, K, L. Okay. Now there's some really cool trig in here that you're going to have to do to get this all right. And that's what we get done today. I'll get you started. But by Wednesday, I want you to have them all laid out. show you what I'm expecting.
What's that small angle under the 12, or not the angle, but like under the 12 on the left? Is that 8?
Here?
Yeah.
8. Yep. Okay. Or see her to pass out under the floor? Oh, okay. As long as I didn't scare her off already. All right, so here's the fun. The angle from our baseline to our road is going to be 60 degrees. Okay? If you're on the north side of it, your angle here will be 120 degrees. Okay? Make sense? Okay. Well, each party is going to do one of the lots. So there are 6 lots you'll set up. You'll have 5 teams, so you'll do 5 lots and 5 parties. Okay? You good, Josh?
Yeah.
Maybe you collapsed on me, Sierra.
Oh, my nose was dripping. I'm a little sick, so I had to play my nose.
So make sure you weren't on the floor, passed out with this monitoring. So here's the fun part, okay? There are things you're going to have to get really good at doing the trig for. Okay? So for instance, I need to know the distance from D to E. Okay? I need to know B to C. Some of these I'm going to give you here in a minute. Okay? But the line distance from C to D, I don't know. Can I figure it out? Luke's nodding his head slightly. How, Luke?
That's where I like was waiting for you to come in.
Okay. You're just assuming that I'm telling you the truth then.
Oh yeah.
Cool. I love that. So if I take this and make a right triangle out of this, can I not figure out what this distance is on that side? Yeah. I know this is 10 feet over here. So that translates across the building as 10 feet. Okay. Otherwise, I would need to do a different dimension over here. If this is going to be 10, let's say it was 12 feet from here to here, okay, which means this line would come in further and come out here. But if I have 30 feet here, and I got 8 feet and 12 feet, that's 20. That leaves me this space to this line up here would be 10, right? Everybody seeing that? So this is part of, you guys take estimating yet? Or maybe you're torturing yourselves through it. Regal and I, by the way, are trying to figure out how to do something different with project management, so it won't be the same torture. So bright lady, just not working out well. It's how to read and interpret all these numbers off the drawing. Okay? This is why this lab is actually all this stuff done ahead of time. Go out and actually shoot and do the layout. And then what we'll do to check you to see if you got it right is, no joke, we know the diagonals from here to here, and we know the diagonals that we want from here to there. And I think there's one more that we have actually established. Okay, and you can check those diagonals all you want because you got all the math sitting in front of you. So the way to know you got it right when you're all said and done is if you call Mr. Ryder and I over to actually do your grading. Pull your diagonals, and you'll know whether or not this corner is square to this corner. Okay. Hanging in there so far? Yeah. So I hate to say the first one's easy, but the first one is easy. Okay. So let me get the roadway back here for a minute. So we're going to put .00 on the road. Okay, you're going to measure over to 12 plus 58.71 if you're party number 1. Who's party 1? Okay. Can you handle that? By now, I'd hope so. You're going to go out and you're going to find that wherever you stuck 12 plus 00 on the road, there's a little pin there. You're going to measure straight back with a steel tape and get yourself offset by 58 feet and 7/10. Okay. All right, from there. From there, we're shooting we want a 60-degree interior angle. Okay. It is the exact same thing. We're just getting a little more specific here. Okay. So I want you to remember, when you did the 60-degree internal angle, which way is the scope turn? Clockwise. I'm aiming here from 12 plus 58.17 to 12.00 to establish where the center line of the road is. What am I swinging? 300 degrees. Okay. But still 60 here, right? Cool. Now, the building will sit down here. Okay. And this will be point B. So that's still 60 degrees. Remember your geometry from high school? 2 parallel lines with a bisecting line, all the interior angles are still equal to each other. Maybe that's not the way it was phrased, but roughly the meaning of it. Okay. Maybe it's still in my world, it's still equal to each other. Okay. But you're going to shoot from 12 plus 58.71 to B. And you're going to get an azimuth equal to 300 degrees, 0 minutes. And that is, I'm going to put it down as station 2B. Okay? And that'll get you off the roadway. All this little bit needs to be accomplished before 3 o'clock. Seriously, come Thursday, 3 o'clock. What goes on up at the hill on 3 o'clock? You've heard me say it many times. Facilities leaves the campus. Right out that access road. Okay? Don't want to get in their way. So, get your gear and get out of here. Okay? Now, the other bit is this. So, you need a distance. So, we're going to do, from that point, all the offsets from the center line of the road are 35.80 feet. So it doesn't matter which party you are, you're going to establish that point. Yes, love.
Is that like an odd number because it's a diagonal line instead of a straight offset?
No, it's just a number that I'd say somebody picked years ago and we keep using. The only thing that may change, and it won't do any damage to you, is when he gets up there, facilities put a whole bunch of little pine trees down through there. Actually, there were 3 of them. One of them was right in the middle of lot 1. It was right where we wanted to put a stake. And he tried to take the hatchet up with him this time, but I'm not sure. So we may get up there and say, okay, instead of 35.8, we're going to make it 40. So you get off the stupid tree. Okay? But until he goes up and lays the center line of the road out again, I'm just guessing at a number. So we're going to try and get that sorted before Wednesday. But everything else after this becomes pretty standard because we're moving the instrument. You're right with this here. We're going to get up here. You're going to find station 12.00. You're going to measure back 12.58. Okay? So that means I'm setting an instrument here, shooting down here, measuring the distance, and marking the ground. Okay? Because that's where I want to move my instrument to next. With me so far? So we're going to back shoot to here. Okay? pin's in the ground, we're good. And you're gonna back shoot to that pin. Then you're gonna zero, shoot 300 degrees here. That'll give you the 60-degree anterior angle that you're looking for. You run a line or a tape out 35.8 feet on that line. Drop a stake at B. Okay. There's some little details we'll work on how to drop stakes properly out there, but okay. So that becomes our new site. Okay. Now we're literally going to go move our instrument to B, because everything else after this is coming off B. Okay. But in order to establish B to A, and this was A up here by the way, B to A, I have to do a backsite to A. Okay. Set that as my 0. After that, 60 to this one will get me over to C. Step 1 complete.
A is
Off the road. A is up here. Yeah, I should write A up here. A is your station that you're looking at here. Okay. So if you wanted to, this is azimuth A to B is 300 degrees. Okay. Given that this is your baseline, and that's established at 0 degrees, 0 minutes, 0 seconds. Okay. Now, there's a few games that we can play here. We could have put you on the point of find your magnetic north, create your azimuth at 0 there, and then swing. But it's easier if you know the line that you're going to be parallel to keep the front of the building parallel to the center of the road. Okay. Okay. Cool. Everybody good on that point? All right. So that was basically establishing B to A. Okay. Now we have the next piece of this puzzle. All right. Oh, and by the way, so the azimuth B to A winds up being re-zeroed as your 0 now. Okay. And then everything else we're going to do after that comes from there.
When you skip 300, you're locking the horizontal on the toll station.
Okay.
Are you moving the vertical to it, like touches the ground, and that's where you?
Yeah, that's how you're just moving to that point. Yeah, we're not looking at anything vertical angles or any of that stuff yet.
If you're looking at the scope of it, you put the cross.
Looking at the scope, put the crosshairs on the PK nail that's established out there. He'll have them put them in the ground, and then there's white paint on them. And if the nails haven't moved from last year, they're still there. So, okay. All right, now we got to look at how to get to the next measurement. Oh, question, yes.
So this is all just group 1, or is this?
This is group 1. You're going to do your own numbers here in a minute. So everybody's going to do them, except group 1 gets a head start.
so each building's going to be different.
Well,
Just
more of the orientation. What's that? Well, it just depends on what side of the road you're flipping on. Okay. All right, so follow along here. Our next piece of this puzzle is we need to establish so we had B right here. That really sucks. B, and then we had C. Okay. And just behind us, we have L. Okay. So we run this clockwise, so we know the next angle is going to be, let me just draw this next shot in here, be that way, going in that direction, okay? But we have a distance from B to C of 17.00 feet. Okay. Now, where did it come from? Well, it came from the architect. I'm giving it to you because it's a lot easier than you guys trying to figure it out. Okay. The other bit over here, as long as we're having some fun, we also have point F over here, which has point E above it, and then we got point D somewhere in there. So as long as we're putting some measurements to life for you, this one is 27 feet. Okay. So keep that one in mind. Not really one I'm worried about right now. Our next step, or intermediate step for this is we need to get B to C. Yes. F is 27 feet away from B.
There you go.
Oh,
It's supposed to be.
sorry, that's an E. Yes. Okay. Now, this step's easy. Is there a lot of math in this to go from B to C? Go ahead, Luke.
No.
Why not? You're right, but why not?
Because it's
It's a
a straight line.
straight line. And I already swung. I've established I have a 60-degree interior angle to this, right? And I want B to C to be parallel to the station center line of the road.
Are we taking the 17 feet?
Oh, yeah. Oh, God, yeah.
You're using the thing.
So you're literally dropping a stroke over a stake with a PK nail in it, and you're trying to go from here to there. And you guys better get yourselves over that dot. Okay. All right.
It's gonna be interesting to tape over a stake that we have a total station over, isn't it?
Oh yeah, that's fun. No joke. So B to C is 17 feet. What's the angle?
180 degrees.
Now, where's my zero now when I move to B?
Oh,
My zero
we're
is
gonna turn
B
60
to A.
degrees clockwise.
So turn 60 degrees clockwise. Okay. So this one is pretty smuckly easy. So we want angle A, B, C to be 60 degrees. Actually, let's do this right. 60 degrees, 0 minutes, 00 seconds. Okay. And we're turning clockwise. Okay. The distance, B to C, 17.00 feet. That's your first entry into your field book. Well, one of the first entries for the data laying out the building. Okay? So far, so good? Okay. Now, here's why I gave you 17 and 27. Good God, that clock's not right either. I got up yesterday morning, all the clocks were right, didn't pay attention to the stove. We went out and did some things, came back into home after 3 o'clock. And I kept looking at the stove. Like, what the hell is that stove? Clock didn't change.
Messes up the hunting schedule.
Yeah. The deer don't care.
Yeah,
They're up at
you
dawn
got
anyways. But what do I have here? Okay. So if I have 17 here and I got 27 there, how many feet between C and F? You agree with him?
Yeah.
Yeah. Only because you're not sure what the hell you're doing right now.
No, shouldn't he agree with me since I said it first?
Oh, you didn't say it loud enough.
Oh.
Be bold. Be proud. State it. If you're wrong, no one's ever gotten slaughtered around here for that. Okay? There would be excuses
You're
for
only wrong if you admit it.
You're only wrong if you admit it. Oh yeah, there's a bad attitude. Okay, so we got 10 here, right? So, what do I need to know to find? And this is going to be the interesting point. So I've established C. I want to know where D is. Okay? But I'm not moving my total station. All shots from here on after will reside from B. Okay? So I'm going to be shooting B to D as my line of sight. I need to know the angle for that. Okay? So let me do a little sketch here. And this is where the comp paper is going to come in handy for you. All right? So we're there. We're going up 60 degrees. Okay. And let's stay here at 60 degrees. Let's do this. Put in purple. I established this as 0 degrees, 0 minutes, 0 seconds. Okay? Right? Okay. What I really want is I want to know what angle I got to shoot for this. Here's B, here's C, there's D. Okay? Do we have some math that we can do to come up with that angle? Okay. All right, so here's the process. And this does require you to sketch this out and have some fun with it. But if I look at, I'm just going to draw this kind of roughly here. If I do this, 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 here, then I get a line down here. Here's C, here's D, here's E, here's F. I know this side to be 10.00 feet. Okay? I know this side here to be 10.00 feet. Okay? What's the other thing I know? Well, I know this interior angle is 60 feet or 60 degrees. Anybody see why I know that? Yeah. Okay. So, can I figure out what C to D is this way? And can I figure out, well, I already know this is 10 feet this way. Okay. What I'd really like to know is what this C to D, and I'm going to use this as, let me make that just a little bit bigger here. I'm going to use this as D prime. Okay. Because that is the distance I want to find out. How much further does that triangle go out? So I can drop the stake right there. Yes? With me? Okay. But I'm not going to do it by coming over to see, going 10 feet, and then making a 3, 4, 5 triangle to come up and hit this at D. Can I check it that way? Absolutely. But here's the thing. I'm way back here at B. Why can't I just shoot an angle to here and figure out the distance I got to go? What kind of triangle I have if you picture that? Take you back to this picture up here. What kind of triangle do I have that's triangle BCD? Obtuse. Can we do obtuse angles? Yeah. What do we need to know?
Law of sines, isn't it?
Law of sines, law of cosines. One of the two. Depends what you know for data. Yes, Landon.
If you extended like the C, like how you have it drawn so it's square, can you just do sine 10?
Oh, you could. and we're going to. We got to do things to get this, okay? But I don't know. So here's my problem, and this is the next step, honestly. So make sure I'm in black here. So I got a side and an angle on the side, right? But I also could find out what CD is. But it'd be really useful to know what this CD prime is, okay? Because I don't know what DE is. With me? Wouldn't it be nice to get two for a price of one? Okay, so I know tangent of a theta is equal to opposite over adjacent, correct? Okay, so put that in terms of what you guys are working with this one. Tangent of 60 degrees is equal to 10.00 feet over CD prime. CD prime is equal to 10.00 feet over the tangent of 60 degrees. Or if you don't like that because it's confusing as hell, the arctangent of 60 degrees times 10 will get you the same answer. Right? Okay. Don't care how you get there as long as you get there. CD prime will be 5.77 feet. Okay, this is for everyone. You're doing the exact same building, just in 5 different locations. Talk about a track home from hell. Okay? So far, so good? Okay. Now, what if I want to know what CD is itself? What's the way to do CD? Do the Pythagorean theorem. Okay? So I'm literally looking for the hypotenuse. So it just happens to be CD is equal to square root of CD prime squared plus, and you can call it e to f squared, okay, because that's at 10 feet. Pretty good? Okay. So when you get all done doing this little bit of math, you should find out that CD is equal to 11.55 feet, okay? So that makes us 11.55 feet. Cool. So far, so good? Anybody lost? All right. That means this is 11.55 feet. We know this is 17.00 feet. I am really interested in this angle in here, okay, from the trig standpoint, but the angle I really want the total station to shoot for me is this one. Okay. So far, so good? Okay. So, let's draw the B, C, D, 11.55, 17.0 here. I'm looking for this angle. Let's, what did I call it? I don't know if I called it anything. So I'm looking for this one. But I know this one, don't I? Because I know this is 60 degrees here. This makes this 120. Okay? So literally, I'm looking for BD is equal to C squared equals A squared plus B squared minus 2AB cosine C, okay? Or in terms of, well, what this is 60 in here. Interior angle from here was 60 degrees. So 60 back to BC would be 120.
Isn't the angle B 62 because it's parallel?
No.
But it's 60 degrees from the road this way.
So the road
Oh,
was up here.
I got it now. Never mind.
Okay. That's my 0 for my instrument. Okay. All right. So once you get all this numbers, let's get equal signing up, 3 lines. The square root of, this had to be B squared over here too. Square root of 17 feet squared plus 11.55 feet squared minus 2 times 17 times 11.55 cosine 120 degrees. Okay? That equals 24 feet, 87 feet. 24.87 feet. With me? Anybody lost? You good, Sierra? Josh, you've been ahead of me already, so. Landon, you good here? Okay. So, literally, what I have left to do is figure out what's this angle over here at B. And then I'm going to take it from that 60, which is my 0 up here, because remember, 60 went all the way from there to here. Right? Actually, it's 1 dash, not 2. Correct? Okay. So how do I find angle B? Law of sines, yep. All right, so we want to go B over sine of B equals 24.87 degrees all over the sine of 120 degrees. B just happens to be the 11.55 that we had earlier, correct? Yeah? Okay. So B is equal to the 11.55 that we had earlier. All right. So when I get all done this math, I wind up with 11.55 feet divided by 24.87 feet. That's feet, not degrees up here. Okay. Times the sine of 120 degrees. And I'm going to get what the sine of B is. Mathematically makes sense to everybody? 0.4022. And if I take reduce that equation down, and I am doing this the hard way just to make sure you're all seeing the math. Okay, I have that equation. Hold on one second. If I take B and I do the arc sine of 0.4022, I'm going to get B to be 23.715 degrees, and I think the 5 repeats a couple times.
Yep.
But once we get like down to H, can we zero in at like G and then spin, or do we always have to go back to that benchmark?
Always got your zero unless you change it on your total station. Will be back between B and A. Everything will come off that measurement. Okay. Cool thing is you don't actually have to go back and shoot somebody standing on the road to do it again. Just gotta get your instrument back there. As long as A, keep me and Mr. Ryder and any other fat feet from kicking the tripod, you're good. Okay. Now hold on, let me finish this up real quick. Okay, so we are literally looking for, we know we got 60 degrees, okay, minus the 23.715 degrees. So we need an angle of 36.28 degrees from our azimuth B to A, which when converted will be, I lost the number. Convert that to degrees, minutes, and seconds. 36 degrees, 17 minutes, 4.27 seconds. Okay, let me go up one more step here and I'll answer your question, Landon, and then I'll get you out here today. So far, so good? Okay. So what I want, when I'm all said and done, I want this angle in here to be, where'd it go? 36 degrees, 17 minutes, 4.27 seconds will be this, okay? This B to D distance here will be the 24.87 feet. Okay? And that's the work you're going to do for every one of these shots to every one of those stakes. Okay? And then you can have yourself some checks because it's as simple as pulling diagonals to see whether or not you have things laid out correctly. So you can figure it out. Now, I want you to do the work by hand, but you could put this bloody thing in AutoCAD, right? I'll take an AutoCAD. Who said this? Now, we gotta get you caught up. I know it's your first advising appointments on you this week. But you can do it all by hand. What's your question?
I figured it out.
Okay. All right. Any questions? Okay. We'll work on this again on Wednesday. But I want you to do some work ahead of time. Get your stuff calculated. That's your homework. I want to see what you've done. If I see it, the grade's 100 for that homework assignment. Even if the numbers are wrong, at least you tried to do the work.
Like all of it, or just starts?
Not at all. Yeah, we're going to check them on Wednesday so that when you're said and done, I can then have you get your field books and fill them out.
If I do an AutoCAD, that's good.
Still got to do all the hand calculations.
My birthday's on Thursday. I don't really want to do this. Can I just get out of it?
So does that mean like
No.
birthday no
Your birthday on Thursday.
But
Yeah.
we will bring a birthday cake out.